Okay, hello everyone. Guys, this is the last topic we're going to cover this year. It's solving radical equations. We're just going to solve and find x, okay, for different radical equations. Again, the last topic of the year. All right, y'all, these are the 4 topics that will be covered on the final test. Okay. Y'all, today's essential question, of course, how do we solve radical equations? All right, here's an example of one right here. Can we isolate this radical term and then square both sides? Because that gets rid of the radical sign then. Squaring both sides gets rid of the radical sign. And then you can solve for x. All right, these are examples of radical equations. Again, they have that square root sign. All right, we're just going to use square roots here. We're just going to solve square roots. All right, one on the bottom is much more difficult. All right, and we're not going to actually have any of those. I'm not going to make you solve the ones that are more difficult, but I want you to understand a concept here, a certain concept. Y'all, these are the 4 steps. Okay, the first step to solving the radical equation is to isolate the radical term, of course. Just isolate it on one side of the equal sign and put everything else on the other side. That way, step number 2, you can square both sides of the equation and eliminate the radical sign, and then solve the equation. The last step, and it's important, is to eliminate any what's called extraneous solutions. The first part of that word is extra. They're like extra solutions that show up algebraically, but they don't actually work in the original equation. Guys, here's an example of just how isolating the radical term. Again, this just says square root of x plus 3. So just subtract 3 from both sides. So you get the square root of 7 or square root of x equals 7. Then you can just square both sides and solve it. And here's another example. Subtract 2 from both sides. The radical term is isolated, so now we can square both sides. That eliminates the radical sign. The 3x just comes outside then. And then you can get rid of the 3 by dividing 3, both sides by 3. Okay? Now here's an example of one as well. When you square both sides, now this side, when you square it, you have to FOIL this because it has 2 terms. All right, so you get a quadratic with 3 terms on this side. All right, however, when you solve it, you end up just with x equals 4 here. Okay, and you can take a look at that example. Guys, the concept I want you to understand here, though, is sometimes when you solve a radical equation, a solution will appear, but it's not an actual real solution because it doesn't work in the original equation. Those are known as extraneous solutions. Now here's an example of one. When you solve this equation right up here, you actually get 2 answers, x equals 5 and x equals 10. And you can plug x equals 10 in here for x, and plug x equals 5 in here for x. And x equals 10 works. You get 7 equals 7 at the end. So it's true. X equals 7 works. But x equals 5 does not work. When we solve this, we get 6 equals 2. Well, 6 doesn't equal 2. Okay, so make sure you do that. Only 10 is the right answer here, even though the 5 showed up when you solved this algebraically. And here's another example where you ended up with 2 answers when you solved this. You plug it back into the original equation. The 3 does not work, but the 7 does work. Okay? Again, you guys, a radical equation, one looks like this. When you square both sides, you can solve this one for x. All right, when solving this equation, though, if two solutions appear, which this one does, the 9 and the 2, only one of those solutions works in the original equation. Guys, and this is a good sentence right here to explain what an extraneous solution is. It's a solution to an equation that is found algebraically. It shows up when you solve it using algebra, but it's not a solution to the original equation. Again, guys, here's the 4 steps. Isolate the radical term, square both sides. That removes the radical. Then solve the equation and check for extraneous solutions. Okay, we'll make it a little bit shorter here today. Again, today's vocabulary assignment is just define extraneous solutions in your own words. All right, and guys, this sentence right here is a good way to explain it. That sentence right there. All right, guys, that's it. Please fill out the notes assignment and the vocabulary and the discussion, all in the green folder. Guys, we're not going to have a second Zoom meeting today. All right, there's just not enough time, I think, for this particular day. One of these days is half and half. All right, so if I think on Tuesday, if this is Tuesday, there will be no second Zoom meeting. All right, that's it. Thanks.